Welcome to Femsa Medical Consultancy channel. Today we'll be looking at another question on friction, that's on applied mathematics, which is suitable for those that want to write a Jupeb exam and for 100 level students, that's for mechanics. Alright, so we have a question. It says a body of mass 10 kg lies on a smooth plane at angle of 30 degrees to the horizontal. If the force 5 Newton acts on the body up and parallel to the plane, find the acceleration of the body down the plane. Alright, the first thing I know, in the previous video, the way we solved that question, a Jupeb question, you see the way I have done all the analysis, so I wouldn't have to do that here. So I hope that some of the statements or my comments can easily be identified with once you have watched the previous video. Okay, so now we have an inclined plane and the angle of inclination is 30 degrees. It's not to scale, so we now have the body. Let's take this as the body on the plane. Alright, so we said that once we have a body this way, the weight will always act downward, and because this plane is inclined, what does that imply? It means that the weight has been displaced through an angle. So the angle of displacement is proportional to the angle of inclination of the plane, okay? So that means we can get that from here. So this angle here is the angle through which the weight of this body had been displayed, which is also going to be 30 degrees relative to the initial line of action of the weight, okay? So now, and once the weight is displaced, you know that it's going to have two components, both the horizontal component and the vertical component. And we have agreed that you can get the horizontal component by getting a line that is parallel to the plane to enclose a right angle triangle here. So you can see that this way. So that means the horizontal component of this weight will be W sine theta, and that's sine 30 degrees, and the vertical will be W cos 30 degrees. We have established that there's a force, an hidden force, that has a tendency of making this body slide down the plane, and that force that is responsible for that is the horizontal component of the weight, which is W sine theta. I'm going to use an arrow to show that force and the direction. So this is W sine 30 degrees. Don't forget, we have been told that the surface is smooth. That's the plane is smooth. That means that the frictional force on that plane is 0. Alright, that means there's no friction. So as a result, this object has a tendency to just slide down. But we were told that if a force of 5 Newton acts on the body up and parallel to the plane, that means we have a force 5 Newton. There are two ways of doing it. It's either you apply it here, trying to push it this way, or you apply it here, 5 Newton acting on the body up the plane. You know, the force can be used to pull, or the force can be used to push the body of the plane. So let's take that as our own conventional direction. So now the next thing we are to find is that we should find the acceleration of the body down the plane. So we need not panic. One of the things we need to take note of is that how many forces are now acting on this body. There are just two now because there's no friction. W sine 30 degrees, which has a tendency to make the body slide down the plane, and 5 Newton that is acting up the plane. Now, which one of them is greater? Until we calculate. Were we given the mass? Yes. That means our W is what? mg. Mg is going to be mass times acceleration due to gravity, and acceleration due to gravity is, we can take that as 10 or 9.8. We're not given. Okay, we can take whichever, we can make use of 10 or we can take 9.8. So conventionally, let's use 10. So if we take 10, that means we're going to have what now? 10 times 10, that's 100. Sine 30 degree is 0.5. Okay, so 100 times 0.5 or times 1/2, that's 50. It's obvious that the W sine 30 degree, I did that to check which one is greater. Alright, even if I don't know the one that is greater, they already told me find the acceleration of the body down the plane. What that means is that what? The direction of the body is down the plane, which implies that W sine 30 degree is greater than 5 Newton that is acting on the plane, on the body up the plane. Alright, so now look at it. Now I can now say that from the figure that I've sketched, okay, the resultant force acting on this body is going to be what? W sine, okay, let me put it, resultant force on the body, okay, resultant force on the body is equal to what? W sine 30 degree minus 5 Newton, because there's no friction. Don't forget, it is this resultant force that will produce the acceleration of the body, because force is product of mass and acceleration due to gravity. Acceleration, not acceleration due to gravity. Resultant force on the body is given by force, is given by mass and the acceleration. So that means I'm going to have MA equal to what? Weight is going to be mg, then sine 30 degree minus 5. So this is going to become, this is the acceleration I'm looking for. So our mass is given by what? That's 10 multiplied by A equal to 10 multiplied by 10 sine 30 degree minus 5. So this is going to be what? All this multiplied will give me 50 minus 5. This is 10A. So this is going to be 45. I have 10A, so that my A is going to be equal to what? 45 divided by 10, and that's what? 4.5 meter per squared seconds. Which of the options now? That's option C. Alright, it's as simple as that. Okay, so that's it. Try as much problems as possible on inclined plane and you see how easy it is. Okay, if there were to be fraction, if it were to be a rough plane, what do you think would have happened? Don't forget, for the body to slide down the plane, that means it must overcome friction. That means what I would have written would have been W sine 30 degree minus 5 Newton minus friction, because friction will always want to oppose the motion. Alright, and the one that will cause the motion to happen is the difference between the friction, this, and this W sine 30 degree. I hope it's clear. The Lord will help you to remember all these concepts in your exams in Jesus' name. God bless you.